Last video you saw how the bits in port B could be used to turn the thinker shield LEDs on and off. You also heard that bits usually move around in bytes, groups of 8. In this video, we'll look at how any group of bits can be viewed as a number, a whole number. We'll also look at a shorter way to write bit patterns, and we'll see counting in action on the LEDs. Okay, bits and numbers. If you've only one bit, the decision's pretty much made for you. 0 is 0 and 1 is 1. Putting a second bit before the first, where it's 0, you still have 0 and 1. Where the new bit is 1, treat it like it adds 2 to the value, and you get 2 and 3. Adding a third bit before the first 2 gets up to 7, with the third bit adding 4 when it's a 1. And you can probably see that a fourth bit will add 8 when it's a 1. A few key points. Each extra bit doubles the possible patterns. Numbers with a single 1 bit are the powers of 2. To convert the bit pattern to a number, you add up all the powers of 2 where there are 1 bits. This explains why we number the bits right to left from 0. The bit number tells you which power of 2 it represents. This is the binary, or base 2, number system. First invented hundreds of years ago, long before computers. You can have a number system with any whole number base, as long as you have enough symbols. Our usual numbers are called decimal, base 10, with 10 symbols, 0 to 9. Look at its key points. You'll see it has a lot in common with binary. If you think about it, the only reason we use base 10 is because we have 10 fingers. If we were Simpsons people, we'd use base 8, octal. A couple of other random thoughts. You can count to 35 on your fingers using base 6. Treat your left hand as sixes and your right hand as units. If you've got good enough control, you can use binary to count all the way to 1023, just on your fingers. You won't get far before making some rude gestures. I won't get into the nitty-gritty of decimal to binary conversion. It's not hard, but it's mechanical and, in all honesty, not very useful. It is useful knowing the powers of 2, at least up to 2 to the 8th, but why not go on to 2 to the 16th? I should mention that this isn't the one and only way that a group of bits can represent a number in a computer. It probably is the most natural, but there are plenty of other ways. We may explore some of them in other videos. Let's see some numbers in ardex. Up till now we've been using binary with the 0b prefix. Numbers without a prefix are treated as decimal. If you scratch your head a bit, you'll see that 50 is 32 plus 16 plus 2. Happily, that matches the pattern in the LEDs. It was much easier to see using binary. Here's a short program that makes for a slightly hypnotic display. The new instruction here is add. In this case, it'll add 1 to whatever's in port B. Pause for a moment, and you should be able to understand the rest of the program. And if we run it, that's what binary counting looks like. The demonstration pretty much speaks for itself. It works through every combination of low bits before toggling the next higher bit. Each bit blinks half as fast as the next lower bit. It never runs out. When the number gets too large to be displayed, it wraps back to 0, like a car odometer. I've already mentioned that decimal to binary is not very useful. That's because programmers seldom use binary. Now, before you get cross with me for wasting your time, programmers do think binary quite a lot. It's just that all those ones and zeros are error-prone to type, and looking at them would make your eyes glaze over. Instead, we use a shorthand, where each symbol stands for 4 bits. We've looked at decimal, we've looked at binary, now we have hexadecimal, hex for short. Perhaps you can guess that hexadecimal means 16, and yes, these are base 16 numbers, where each digit is 16 times the value of the digit to its right. That means we need 16 symbols. We can use 0 to 9, but then what? You'll be glad to know that they didn't decide on weird new symbols or Greek letters or whatever. They simply used the first 6 letters of the alphabet, A to F, to fill the gap. They even kept them in the usual order. With hex, you count as usual up to 9, then you go through A, B, C, D, E, F, before 10, 11, 12, and so on. Saying the digits one at a time rather than 10, 11, 12 is a hint that we aren't using decimal. Once you're used to it, when you see hex 32, you can see the bit pattern is 3, 0, 0, 1, 1, 2, 0, 0, 1, 0. You go straight to binary, 4 bits at a time. Pretty easy. It's also not too bad to convert to decimal. 32 is 3 times 16 plus 2, 50. Handy if you know your 16 times table. Now an important point. The reason to choose a particular base is for your convenience. Decimal, binary and hex are just ways of representing bit patterns. In the end, that's all the computer cares about. ardex has a base command, which converts numbers between binary, hex and decimal. You remember that binary numbers are prefixed with 0b. Hex numbers are similarly prefixed with 0x. This was popularized by the C programming language and is used in many modern languages. You might like to try a few conversions to see how closely related hex and binary are and how different decimal is. Go through the powers of 2, for example, or 1 less than each power of 2. Both interesting to see. In a boring way, of course. List is another command you should know about. It lists instructions in the computer's program memory. If we entered Blinky from the first video, this time using hex, the program works as before, with the top and bottom LEDs blinking. We can look at the instructions using the list command. Notice that the hex 21 has been replaced with decimal 33. Same value, but not as handy for knowing which LEDs will be lit. This happens because ardex doesn't have enough memory to store everything you type. Each instruction is turned into 3 bytes, and ardex forgets that you type the numbers in hex. By default, all numbers are listed in decimal. You can use the base 16 command to tell ardex to use hex, which fixes the bit patterns, but now the wait durations aren't much use. The proper solution is that programs are best edited on your computer and then uploaded to ardex to run. It's hardly a big deal with Blinky. Sorry that this video has been a bit technical, but it is important that you get familiar with hex. Future videos will make little if any use of binary numbers. Next video we'll look at the major parts of a computer and how they work together. Have fun!